Hello, this is Dr. Anyashola Ogundele, Astronautics for Exploit. In-space manufacturing strategies and technologies. The focus points of my presentation are as follows: in-space material requirements and usage, and in-space manufacturing strategies and technologies. In-space manufacturing, the process of manufacturing products in space using extracted natural space resources such as asteroids, moon, and Mars resources, utilizes advantages of space vacuum, microgravity, and space environments to manufacture products that will be impossible to manufacture on the Earth. Over the years, autonomous and robotic systems that provide intelligence services and information by interacting with their environments, including human beings, using various sensors, actuators, and human interfaces, have contributed immensely to the successfulness of human beings' aspirations to conquer new worlds through space exploration and enablement of scientific breakthrough. In the future, in-orbit manufacturing will be one of the determining factors that would determine how far humans will be able to engage in robotics and manned deep space exploration missions. In-space manufacturing offers various potential benefits such as reduction of maintenance logistics, enablement of the use of recycled materials and in-situ resources, enablement of flexibility, mitigation of risks, and manufacturing of space products that will be free from Earth's gravity pull constraint. In preparation for the future space exploration missions, various in-space manufacturing strategies and technologies such as in-space servicing, in-space robotics manufacturing, 3D printing in space, additive manufacturing, and in-space material processing are being developed. Due to the increase in launching of satellites to perform various purposes, on-orbit satellite servicing industry is developing new technologies which will help to make space a sustainable environment. For example, Space Logistics, which is one of several on-orbit satellite servicing companies, is looking into how to use new technologies to perform life extension work on current and future satellites. The 3D printing in zero-G International Spacecraft Technology Demonstration was the first time that additive manufacturing, which is 3D printing technology, was performed in space. In-space material requirements and usage. For most manufacturing applications, specific material requirements must be satisfied. Mineral ores need to be refined so as to extract specific metals and volatile organic compounds, which will need to be purified. Ideally, it is expected that raw materials are delivered to the in-orbit or on the moon processing site in an economical manner, where time to arrival, propulsion energy expenditure, and extraction cost are factored into the planning process. This picture shows artist's impression of Hayabusa spacecraft approaching the Itokawa asteroid in the year 2010. Minerals can be obtained from asteroids, the lunar surface, or a planetary body. Volatiles could potentially be obtained from a comet, carbonaceous chondrite, or C-type asteroids, or the moons of Mars or other planets. Unless the materials processing and the manufacturing sites are co-located with the resource extraction facilities, the raw materials will need to be moved about the solar system. This picture shows illustration of asteroid mining. Materials can be used for manufacturing either in their raw form or by processing them to extract the constituent elements. Processing techniques. Processing techniques include various chemical, thermal, electrolytic, and magnetic methods for separation. In the near term, relatively straightforward methods can be used so as to extract aluminium, iron, oxygen, and silicon from lunar and asteroidal sources. This picture shows ESA's ERA mission to the Didymos binary asteroid system. There are different in-space manufacturing strategies and technologies that are currently being developed, and some of them are in-space servicing, in-space robotics manufacturing, 3D printing in space, additive manufacturing, in-space recycling and reuse technology, and in-space material processing. In-space servicing. Satellites provide an abundance of services such as communications, Earth observation, navigation, research purposes, and a host of others. This picture shows an artist's illustration of the low Earth orbit night space robot. Satellites are designed for a particular lifespan, for example 15 years. How long a satellite is able to spend in orbit is a function of amount of fuel on board. Even if a satellite's payload and bus are still fully functional, a satellite with an empty fuel tank will no longer be of use, and most of them will be sent to the graveyard orbit. This picture shows a clean space once debris collecting satellite that could be deployed as soon as it renders for with its target space chunk. As satellites from both the commercial and defense sectors continue to proliferate, the unorbit satellite servicing industry is offering new systems to make space a more sustainable environment. Space Logistics is one of several on-orbit satellite servicing companies looking to use new technologies to perform life extension work on current and future satellites. This picture shows illustration of the Regolith Advanced Service Systems Operations Robot, a conceptual in-space construction system and lunar rover on the moon. In-space robotics manufacturing is another in-space manufacturing strategy and technology. A space robot, which is a machine capable of automatically executing complex tasks, is specially designed to perform a specific task in space. Space robots may be controlled by a human with a control device by a computer to which it is connected, or completely autonomous. This picture shows an artist's impression of an asteroid mining outpost. Orbital robotics. The main areas of space robotics are orbital robotics and planetary rovers and landers. Orbital robotics perform autonomous tasks in space, for example, International Space Station operations and satellite servicing. Planetary rovers and landers, which is another area of space robotics. They are designed to operate in the service of the planets and moons of the solar system. They are useful for planets, asteroids, and comets exploration. This picture shows space infrastructure dexterous robot technology demonstration. The payload will assemble a functional communications antenna and manufacture a spacecraft beam. Present and future manned and robotic space exploration missions are dependent on space robotics. There are a lot of proposals for in-space robotics manufacturing technologies which will in turn help to enhance existing space assets and create new ones. This picture shows the Streg robot on the International Space Station. Space robot manufacturing challenges. In space, robots are used every day. The space environment, such as high radiation levels, extreme thermal changes, and a host of others, pose challenges to the manufacturing of robots in space. For space robots manufacturing to be successful, they must be carefully and specially designed. This picture shows Mars Curiosity rover taking a self-portrait on a Martian sand dune. Another technology that is being developed for in-space manufacturing is 3D printing. Off-Earth manufacturing is taking a giant leap for the manufacturing in space. Presently, efforts are being directed at manufacturing objects in space. 3D printing technology. In-space manufacturing using 3D printing technology is presently receiving high attention. This picture shows testing of the made-in-space 3D printer, which was launched in 2014. It involved 400 plus parabolas of microgravity test flights. 3D printing in space. The 3D printing in zero-gravity International Space Station technology demonstration was the first time that additive manufacturing, which is 3D printing, was performed in space. This picture shows illustration of a ratchet wrench created in 2014 with a 3D printer aboard the International Space Station using a design file transmitted from the ground. In collaboration with Made in Space, NASA used a 3D printer for 2 rounds of operations from 2014 to 2016. The project investigated the effects of consistent microgravity on matte deposition additive manufacturing of a common polymer material. This picture shows 3D printing technique building plan for Moon and Mars bases. Additive manufacturing is another technology for in-space manufacturing that is being developed. Additive manufacturing allows the creation of lighter, more complex design. It uses computer-aided design software or 3D object scanners to direct hardware to deposit material, layer upon layer, in precise geometric shapes. Additive manufacturing delivers a perfect and improved performance, complex geometries, and simplified fabrication. This picture shows 3D printed lunar base. Aquanaut spacecraft assembly technology. NASA has awarded a contract to Made in Space to perform orbital tests of its Aquanaut spacecraft assembly technology. The Aquanaut 1 demonstration spacecraft is planned to be launched to low Earth orbit aboard a Rocket Lab Electron booster in 2022. Once in orbit, Aquanaut 1 will 3D print 2 32-foot long beams, which will extend from each side of the space. This picture shows illustration of Aquanaut assembling a satellite platform much larger than itself. Aquanaut system is designed to be able to robotically create spacecraft in space, which reduces spacecraft cost, the limitations rocket launch places on spacecraft design, and removes astronauts from harm's way. This picture shows Made in Space building of the Aquanaut 1 spacecraft to additively manufacture and robotically integrate a pair of 10-meter solar arrays to expand the small satellite's ability to generate power. Additive manufacturing facility is a commercial facility from Made in Space, a multi-material 3D printer for polymers. AMF manufactures with high-density polymer and ABS, which is the most common plastic material for 3D printing and the focus of the original 3D printing in zero-G experiment. This picture shows a printed product floating in front of the AMF on the International Space Station. In-space recycling and reuse technology is another in-space manufacturing technology being developed. Using recycled material for printer feedstock could save future long-duration exploration missions from having to carry a large supply of material for 3D printing. Recycling also could make use of material that otherwise would represent a nuisance or a trash disposal issue in the space mission. This picture shows on-orbit satellite servicing. In-space recycling capability. As a step towards in-space recycling and reuse capability, the refabricator investigation technology, developed by Status Unlimited to recycle waste plastic materials, including previously printed items, into high-quality 3D printer filament, is being demonstrated. This picture shows an artist's rendition of proposed ED-orbit mission using a robotic arm to catch a derelict satellite. Refabricator. Refabricator unit was flown to International Space Station in 2019. Its reuse capability enables NASA to close the manufacturing loop on long-duration missions so that the feedstock for the printers does not have to be launched. This picture shows Akinaut, a demonstration of in-space manufacturing and assembly technologies. For more information, contact Astronautics for Exploit. You've been watching and listening to In-Space Manufacturing Strategies and Technologies, presented by Dr. Ayeshola Ogundele, Astronautics for Exploit. Thank you.